Okay, so physics class. We started breaking up components into x and y direction, or started breaking up our magnitudes into x and y components. Okay, so given a resultant, or a magnitude is a better word for this. Given a magnitude, it has both an x and y component to it. And the way we break them up is to say x, we would say magnitude cosine of the angle theta. Y being magnitude sine the angle theta. Okay? Well, these magnitudes extend to more than just distance and position and mass. Okay? They extend into velocities and accelerations. One example is acceleration due to gravity. Acceleration, watching from a previous video, is the increase of speed towards, the increase of speed or the decrease of speed. Acceleration due to gravity is the increase of speed as something is falling towards the earth. Okay? The increase of speed as something is falling towards the earth. As things fall, they fall at a rate of 9.8 meters per second squared. So that means after 1 second of falling, it has a speed of a velocity of 9.8 meters per second traveling towards the earth. Okay? And after 2 seconds, just multiply that by 2, and that's what the velocity would have increased to as something is falling towards the earth. Now, that is acceleration in the y direction. Okay? How much of that gravity affects things going in the x direction, traveling along the x direction? How much of that gravity influences those things traveling along the x direction? Zero. Zero. Okay? Zero. So for one slight example, I'll do a small example. Objects with velocity in the x direction, speed, is not affected by gravity. They are not affected by gravity. You do not put gravity in a Vx formula. So to solve a particular problem, here we go. An object falls from a height of 10 meters. How long did it fall for? Okay, using one of our basic concepts here, our basic formulas, we want to know how long it fell for. What do we have? We have 10 meters, okay? 10 meters. D is 10 meters. D, which is synonymous with height, is 10 meters. Okay? All right, how much of this is in the x direction? Zero. None of it. None of it is in the x direction. Okay? So let's start filling in what we have. Okay? Acceleration. What is our acceleration? Our acceleration is in the y direction. 10 meters. Height, 10 meters. Is that x or y? That is the y direction. Height. Height is defining something perpendicular to the horizontal. Height defined by the y direction, or the y measurement. So acceleration due to gravity is in the y direction as well. 9.81 meters per second squared. Mm-hmm. Do we have an initial velocity? Well, if we did, it would have to be in the y direction. Did we give it any initial velocity here? No, we did not. So it is 0 meters per second. 0 meters per second. So let's fill in what numbers we do have, okay? Filling it in, we say 10 is equal to 0 times t plus 1/2 times it would be a negative 9.8 as it is falling towards Earth, negative 9.81. To make things a little easier, there isn't another direction. We're going to make this 9.8 positive for now. Times t squared. Okay? Hey, so 0 times t, we can get rid of this because anything times 0 is 0. Very good. So 10 is equal to 1/2 times 9.81 times t squared. You go ahead and pause it real quick. Okay, so 10 is equal to 1/2 times 9.81 t squared. Hey, what do we have to solve for? How long did it fall for? We're looking for time, okay? Time in seconds, all right? So let's solve for that. How do we start getting time by itself? Well, we multiply 2 to both sides, okay? 2 times 10 is equal to 2 times 1/2 is just 1. So we end up just having a 1 right there. 9.81 times t squared. Okay? Hey, all right, so what do we do next? How do we get t by itself? We divide both sides by 9.8. Okay? All right, now you have, I'll rewrite it over here, 2 times 10 divided by 9.81 equals t squared. All right? Now, how do you get that t to just say t instead of t squared? Very good, you take the square root. T is equal to the square root of, I'm just going to multiply those two together if everyone's okay with that, 20 divided by 9.81. Okay, 20 divided by 9.81. Square root of 20 divided by 9.81, and you get a time of 1.42 seconds. Okay, you get a time of 1.42 seconds. All right, that's a definition. Let's just do a slight recap. Things being shot into the air have an x and y direction. We'll go more into that in a few other examples later on. But gravity is a very popular acceleration. It only affects things in the y direction. Okay, a sub y. All positions, velocities, and accelerations have an x and y component. You have to keep that in mind when solving these problems. Okay. Objects in the x direction are not affected by influences in the y direction. So if you have a car moving along the road, it is not particularly affected by gravity as to how fast it's going along the road, okay, or how far it's going to be going. Okay, so and then of course we solved this example of an object falling from a particular height. Thank you very much and look forward to the next video. Have a nice day.